Supreetha, welcome to my math class. In the previous lectures, we studied about Laplace transform. Yes, so in this lecture, let me start with inverse Laplace transform. Okay, so what is this inverse Laplace transform? Say I have, okay, suppose I have Laplace of A. What was Laplace of A? Laplace of A was A divided by S. Okay, now what would happen if this L, this function goes to the RHS? It would become Laplace inverse. Okay, so in Laplace unit, you would get find the Laplace of A. The question would be something like this. In the inverse Laplace, you might get find the Laplace inverse of A by S. You would have to write A. Okay, let me take that formula list that we had in Laplace. This was the formula list. Agree? So, f of t, this was f of t. Okay, this was f of t. We had Laplace of f of t. Okay. Now, what would happen if I send this Laplace to the other side? It would become Laplace inverse. That is, the left table, that is the left terms would become Laplace inverse of f of t. And here can I write f of s? Why? Because this is equal to f of s, right? So let me replace even these terms. Okay. So this would become f of s and this would be our Laplace inverse of t. This is our Laplace inverse of t and this is our f of s. This is the formula list for inverse Laplace transform. Okay, let me write on the first question. Okay, find the inverse Laplace transform of, the question would be like, find the inverse Laplace transform of 1 divided by s cube, inverse Laplace transform of 1 divided by s cube. Observe, what do we have here? Can I apply the first one? No, right? The second one also I cannot apply. I can apply the third formula. Okay, so what is Laplace transform of t power n? Laplace transform of t power n is n factorial divided by s to the power n plus 1. Okay, can I send this n factorial to the LHS? What would I get? I would get 1 divided by n factorial into Laplace of t power n. This is equal to what? 1 divided by s to the power n plus 1. Can I take this 1 divided by n factorial inside the bracket? I would get t power n divided by n factorial. This is equal to 1 divided by n plus 1. So what happens now? T power n divided by n factorial is, if L goes to the other side, it becomes L inverse, that is Laplace inverse. Okay, can I change this formula to? Yes, I'll change that formula to what? Laplace inverse of 1 divided by, okay, 1 divided by s to the power n plus 1 is equal to how much? T power n divided by n factorial. So here I'll replace the question as 1 divided by s to the power 2 plus 1. Okay, what is the formula? L inverse of 1 divided by s n plus 1. This is equal to t power n divided by n factorial. What do I have in place of n? Observe, we have 2, right? So let me write this as t to the power 2 divided by 2 factorial. That is t square divided by 2. Okay, as you can observe, in the question we have all the s terms. In the answer, I have converted everything to the t terms. Okay, so let me write on the next question, that is, find the Laplace inverse of 2 divided by, yes, 2 divided by s plus 3. What should I find? I should find Laplace inverse of 2 divided by s plus 3, right? Okay, let me change the question to 3, or 2 also would be fine. Anything is fine. s plus 3, s plus 3. So this is equal to, can I take 2 outside? It is a constant, right? So I'll write it like this. Observe the formula list. Which formula can I apply? I can apply the second formula. Okay, what do I have? 1 divided by s plus 3. I'll write it as 2 Laplace inverse of 1 divided by s minus of minus 3. Okay, what is Laplace inverse of 1 divided by s minus a? This is equal to e power at. Okay, yes, what do I have in place of a? I have, this is equal to 2 e power minus 3t. Okay, so now let me write down the third question. That is, third question, say we have 5s divided by s square plus 9. What should we find? We should find Laplace inverse of 5s divided by s square plus 9. 5 is a constant. Let me take that out. Laplace inverse of s divided by s square plus, I'll write 9 as 3 square. Observe the formula list now. We have s divided by s square plus a square, right? That is how we write the formula. Yes, what is s divided by s square plus a square? It is cos at. Okay, so now what I'll do? I'll just write down the formula. That is Laplace inverse of s divided by s square plus a square is equal to cos a t. So our answer would be 5 into cos, in place of a I have 3, so that would be cos 3t. Okay, so the next question is fourth one. Okay, find the inverse Laplace transform of 1 divided by 3s square plus 16. Okay, that is Laplace inverse of 1 divided by 3s square plus 16. Observe the formula list. Yes, in the formula list, for s square, we don't have any coefficient, right? So let me eliminate that coefficient. How would I do that? I'll multiply. Yes, I'll multiply the whole thing and divide it with 3. What would happen then? This is 3 into 3. Okay, so I would get Laplace inverse of 1 divided by 3 into, I can divide each term with 3, right? I'll get s square plus 16 divided by 3. Okay, so this is equal to, I'll take out 1 by 3, Laplace inverse of 1 divided by s square plus 16 divided by 3. This is equal to 1 divided by 3. Yes, Laplace inverse of, observe in the formula, if you have s square, you should also have a square for every formula. So I already have s square plus whatever term I have, I'll write it as square of something. Okay, so this would be 1 divided by s square plus 16, I can write it as 4 square. Okay, 3 I'll write it as root 3 the whole square. Okay, because it is not a perfect square. Okay, so this would be 1 divided by 3 Laplace inverse of 1 divided by s square plus 4 divided by root 3 the whole square. So what do I have here? 1 divided by s square plus a square. What is the formula? Laplace inverse of 1 divided by s square plus a square. What is the formula? Observe, if we had s, we could have taken cos at, but we have only 1. Let me simplify this. Laplace of sin at. Laplace of sin at is equal to a divided by s square plus a square. A is a constant. I'll send it to the LHS. It would be Laplace of sine AT is equal to 1 divided by S square plus A square. Can I take this A inside the Laplace? Yes, because it is a constant. Divided by A is equal to 1 divided by S square plus A square. What happens to the Laplace if it is shifted to the RHS? It becomes Laplace inverse. Okay. Laplace inverse of 1 divided by S square plus A square. So let me change the formula here. Here I would get 1, right? Here I would get 1. Here I would get divided by A. Yes? So here let me write down the formula. That is Laplace inverse of 1 divided by square plus A square is what? Sine AT divided by A. Okay? So my answer would be, this is equal to 1 by 3 into sine. In place of A I have what? 4 by root 3 into T divided by 4 divided by root 3, or I can also write it as root 3 divided by 4 into 3, okay, sine 4 by root 3 into T. I'll write this root 3 as root 3 into root 3. Why? Root 3 into root 3 is 3 itself. So this would become 1 divided by 4 root 3 sine 4 by root 3 into T. What is this? This is our Laplace transform or inverse Laplace transform of the given function. Okay, moving on to our next question, that is, yes, find the Laplace inverse of 2s minus 1 divided by s square plus 8. What should I do? In all the formulas, I have only one term in the numerator, right? So I'll just split the terms. That is Laplace inverse of 2s divided by s square plus 8 minus Laplace inverse of, or else let me first write it as, here only I'll write minus 1 divided by s square plus 8. If I take the LCM, I would get back the previous step. Okay, so this would be Laplace inverse of 2s divided by s square plus 8 minus Laplace inverse of 1 divided by s square plus 8. Okay, so what would I get? 2 is a constant, I'll take it out. Laplace inverse of s divided by s square plus 8 minus Laplace inverse of 1 divided by s square plus 8. Okay, so that would be Laplace inverse of, I'll write 8 as root 8 the whole square. Why? 8 is not a perfect square, right? So minus Laplace inverse of 1 divided by s square plus root 8 the whole square. Okay, so now what is Laplace inverse of s divided by s square plus a square? Okay, Laplace inverse of s divided by s square plus a square is what? It is cos at. Okay, what is Laplace inverse of 1 divided by s square plus a square? It is sin at divided by a. Okay, so now what should I write over here? This is equal to 2 times cos root 8 into t minus sine root 8 into t divided by root 8. Okay, this is our Laplace transform of the given question. Okay, now let me write down the next problem. Yeah, find the Laplace inverse Laplace transform of, that is the sixth one. Yes, 3s square plus 4 divided by s to the power 4. Whenever I have two terms in the numerator, what should I do? I should divide it with each term. So Laplace inverse of this, right? The question is what? 3s square. This is not s square. It is 3s square. Okay. So Laplace inverse of 3s square divided by s to the power 4 plus 4 divided by s to the power 4. Okay. So what is this? Square minus 2. So I'll get Laplace inverse of 1 divided by s square plus Laplace inverse of, I'll take out 4 because it is a constant, 1 divided by s to the power 4. Okay. What is the formula? The formula of Laplace inverse of 1 divided by s to the power n plus 1 is t power n divided by n factorial. Okay. Can I write 2 as 1 plus 1? Yes. I'll write 2 as what? 1 plus 1. So in place of n, what do I have? I have 1. So I'll write it as t power 1 divided by 1 factorial, which is 1 itself. Plus, I'll write this 4 as 3 plus 1. Yes, 4 is equal to 3 plus 1. So in place of n, what do I have? I have 3. So I would have to write t cube divided by 3 factorial. Okay, so I would get t plus 4 divided by 6, which is nothing but 2s are 3s are t cube. I would have to write it as t plus 2 divided by 3 into t cube. Okay, moving on to our next question. Let me write down the 7th one. That is, the 7th one is, yes, find the inverse Laplace transform of 3s minus 4 divided by 16 minus s square. As I told you, if you have two terms in the numerator, what should you do? Divide each term. Okay, that is, write it as 3s divided by 16 minus s square minus 4 divided by 16 minus s square. Okay, observe the formula list. We never had a square minus s square in the denominator. We always had s square minus a square. Okay, what is this? Okay, I have plus into 16 minus s square, right, in the denominator. What is the sign change rule? If you change the sign outside the bracket, you would have to change the sign even inside the bracket. Means what? If I change this plus to negative, inside the bracket, plus 16 would become minus 16. Minus s square would become plus s square. Okay, so what would I have here? Laplace inverse of, I'll take out 3, it is a constant. S divided by, I have a negative sign, s square minus 16. Okay, minus 16 plus s square, I'll write it as s square minus 16. Okay, here I have minus. From the denominator, I would get 1 minus. It would become plus 4 divided by s square minus 16. Okay, now what should I do? I'll apply Laplace inverse. Okay, I cannot take 3 common here. Okay, in the next step, I'll take it out. This is 3. I'll write it as 3 Laplace inverse of s divided by s square minus 4 square plus Laplace inverse of 4 divided by s square minus 4 square. Okay, what is Laplace inverse of s square? S divided by s square minus 4 square. Let me get back to the formula list. Okay, Laplace inverse of s square minus a square is cos hyperbolic. Yes, Laplace inverse of s divided by s square minus a square. Let me write down the formula. That is Laplace inverse of s divided by s square minus a square is what? Cos hyperbolic at. And Laplace inverse of a divided by s square minus a square, this is equal to sine hyperbolic at. So let me substitute these here. Okay, so what do we have? We have 3 Laplace inverse of s divided by s square minus a square, which is which is cos hyperbolic. In place of a, what do I have? I have 4. That would be 4t plus I have a divided by s square minus a square directly. So I'll write it as sine hyperbolic 4t. Okay, this is a Laplace inverse of the given question. Okay, let me take down one more question, say 7th one. Okay, find the Laplace inverse of, yes, 7th one, find the Laplace inverse of 1 divided by s minus 2 divided by s square plus 5 divided by s to the power 4. Let me write down the formula first. That is Laplace inverse of 1 divided by s to the power n plus 1 is equal to t power n divided by n factorial. Okay, so here let me give Laplace to each term. Laplace inverse of 1 divided by s minus Laplace inverse of 2 is a constant, I'll take it out. I can write this as 1 divided by s to the power 1 plus 1. Okay, here I can write it as 0 plus 1. Okay, plus 5 is a constant. Laplace inverse of 1 divided by s to the power 3 plus 1. Okay, so this would be, in place of n, what do I have? I have 0 here. So it would be 0 factorial, t to the power 0 divided by 0 factorial, which is 1. Okay, or you can directly say Laplace inverse of 1 divided by s is 1. Okay, what was the formula? Laplace inverse of a divided by s is what? A. Okay, minus 2 into, in place of n I have 1. So that would be t divided by 1 factorial plus 5 t cube divided by 3 factorial. Okay, this is our Laplace inverse of the given question. Yes, so the next question is, that is 8th one. 1 divided by s plus 2 plus 3 divided by 2s plus 5 minus 4 divided by 3s minus 2. What is the first step? I want only s here. I want it free from this 2. So what I'll do? Yes, Laplace inverse of this given question. I'll multiply and divide it with 2. Here, I'll multiply and divide it with 3. What would I get? 1 divided by s minus of minus 2 plus 3 divided by 2 into s minus of minus 5 by 2 minus 4 divided by 3 into s minus 2 by 3. Okay, what is the formula that we use here? The formula that we use here is Laplace inverse of 1 divided by s minus a is e to the power at. That is why I wrote plus 2 as minus of minus 2. Okay, so now I would write this as, this is equal to e to the power minus 2t plus 3 divided by 2 e to the power minus 5 by 2t minus 4 by 3 is a constant, and this would be e to the power 2 by 3 into t. Okay, let me write down Laplace here. What is all this? This is Laplace inverse of. Okay, Laplace inverse of the given function. Yes, let me solve one more problem. That is the 9th one. They're asking us to find Laplace inverse of s plus 2 divided by s square plus 36 plus 4s minus 1 divided by s square plus 25. What did I tell you? If you have two terms in the numerator, okay, when you have two terms in the denominator, give each term to the denominator. What do you mean by that? Laplace inverse of this. That is Laplace inverse of s plus 2 divided by s square plus 36 plus Laplace inverse of 4s minus 1 divided by s square plus 25. So this would be Laplace inverse of s divided by s square plus 36 plus 2 divided by s square plus 36. Okay, plus Laplace inverse of 4s divided by s square plus 25. Okay, that's what I'm doing. I'm giving each term. In the numerator, I'm giving each term to the denominator. If I take the LCM, I would get the previous step. Okay, so this would be Laplace inverse of s divided by s square plus 6 square, right? 36 I can write it as 6 square. I'll take 2 common. I would have 1 divided by s square plus 6 square plus Laplace inverse of 4 is a constant. I'll take it out. S divided by s square plus 5 square, right? 25 you can write it as it is a perfect square. I'll write it as 5 square. Laplace inverse of 1 divided by s square plus 5 square. Okay. Now, what is Laplace inverse of s divided by s square plus a square? Let me write on the formulas. What was Laplace inverse of s divided by s square plus a square is what? This is equal to cos at. Okay, Laplace inverse of 1 divided by s square plus a square is what? Sin at. Okay, we use these two formulas over here clearly. So for the first one, what do I have? S divided by s square plus a square. So that would be cos 60 plus 2 I'll write down as it is. I have 1 divided by, right? So I would get a divided by a here. So I would have to write sin 60 divided by 6 plus 4 into cos 5t divided by 5 minus again sin 5t divided by 5. Here we wouldn't get divided by 5, right? Let me erase that. Observe the formula. We don't have divided by 5 for cos 80. Okay. So what did we study in this lecture? We studied inverse Laplace transform. What is inverse Laplace transform? It is just a flip of Laplace transform. Okay. The question here is the answer there. The answer there is the question here. Something like that. Okay. So yes, how did we solve it? What were the major things? You just have to memorize these formulas. Okay. If they would have given you f of s, we would have to find f of t. Okay. So yes, that is it for today's class. Thank you.